Good morning. My name is Carla Carvajal. I am a Polygence scholar, and today I will be talking about microgrids and their benefits in the Dominican Republic. I'm currently recording from Fredericton, New Brunswick, and I have an interest in cleaner energy solutions as well as renewable energy sources, in particular in developing countries like Dominican Republic. So, how this project was born? This project was born in November 4, 2022. I remember being in a friend's house. We were located in Los Prados, which was a area that was very affected by the floods. Um, I remember sitting on the balcony and watching with tears in my eyes how my city disappeared. And I remember crying, and just taking my laptop out, opening our Word document and thinking about how can I help my country be better? How can I find a solution for this? So that was the day this idea was born, and why I decided to create a project that is focused on the benefits and the potential of microgrids in the Dominican Republic. As you can see in this picture, this is the back of my house. And this was in November, and how bad was the plot, and everything was just the cars were being carried away. And it was just a very hard moment for me and for any Dominican in that time. So I just feel this is a way I demonstrate there's still hope for my country, and that we can still help our country to respond in an effective way when it comes to natural hazards and environmental catastrophes. So let's continue. So what are microgrids? Microgrids are small interconnected energy resources that function as a singular integrated unit concerning the grid. They are self-sufficient systems that can be used to respond effectively to unplanned outages by operating either in islanded mode or hybrid mode. And when it's in hybrid mode, it's like the best of both worlds. It's like it takes the advantages of conventional but also renewable energy resources. So what are the benefits of microgrids? Microgrids offer different benefits that range from reducing energy risk, reliability, but also like improving flexibility and increasing environmental benefits. In the economical aspect, microgrids are leading the way as the cost of PV system has continued to decline in the following years when it comes to the commercial, utility, and residential sectors. And this reduction in energy costs has led to an increase in PV deployment of over 20% in 2022. Another benefit of microgrids is that they offer that secure energy supply for infrastructure in case of emergency. So why did we choose microgrids for the Dominican Republic? Why the Dominican Republic? So, well, the Dominican Republic has a bright future powered by the endless potential of the sun. And when I say that, it's because we have a high solar irradiance, which is one of the important factors that is essential when it comes to the integration of PV systems, because the amount of irradiance in watts per meter square by the solar panels determine the maximum energy level generated by each solar panel. And this solar radiance is shaped by certain elements. This includes its spatial position, the weather, the topographic composition, the cloud coverage, and many others. So, for instance, countries that are located near the equator, like the Dominican Republic, have a high solar irradiance because the distance that the sun's radiation must travel to reach the surface is shorter and also stronger. And also another factor is air pollutants, where a country has a lot of air pollution, means that there is like less solar radiation because it acts as a boundary, like as an entry, like it allows the solar radiation to be absorbed but also scattered. And it scatters the sunlight that is attempting to reach the solar panel surface. Um, so how does this apply to the Dominican Republic? Why do we say the Dominican Republic has a high solar irradiance? Well, we say that because the potential that varies between the eastern half of the country The solar potential or the solar radiation for the Dominican Republic is 5.25 to 5.50 kilowatts per hours per meter square in the eastern half of the country. And for the western half of the country, it's like 5.50 kilowatts per hours to 6.0 kilowatts per hour per meter square in the western half. So this is a very high amount that if we take action can help allocate the 83% of the energy production that currently pertains to non-renewable energy sources towards photovoltaic energy production, which currently represents 2.2% of the total installed capacity. Another factor that makes the Dominican Republic a good place for solar energy production is climate vulnerability, because it's currently ranked as the 50 most vulnerable country to climate change. And it has been attacked by hurricanes like Irma and Maria, would have created damages that reached 34.9 million US dollars. And these two hurricanes, along the hurricanes that hit the Dominican Republic in 2022, represented 1% of public spending, which is a very high amount. But with microgrids, it can be reduced. The third factor that makes the Dominican Republic a good place is current energy landscape, because the Dominican Republic has a lot of significant supply challenges, specifically supply challenges and distribution losses that are either caused by commercial obstacles, the dependency of the country on fossil fuels, but also the government's reliance on oil imports. To illustrate this, in 2023, the energy loss accumulated by the electricity distribution companies in El Sur, El Norte, and El Este reached 35.9%. This figure was 4.1 points higher when compared to 2022. And finally, the last item that I think is very important and that makes a lot of easier the microgrid implementation is the government support. So in 2007, the law 5706 was passed, and it has a net metering program, which basically allows residential entities that do not exceed 25 kilowatts, and also commercial entities that do not exceed 1 megawatt to receive credits when their production is greater than consumption. This law also has import tax exemption, which is very important. So after conducting this analysis and just like mentioning the factors that make the Dominican Republic a good place for microgrid implementation, we use energy access tool as a visualization tool for our methodology aspect of our paper. So with this tool, we just basically presented the map of each provinces and why will microgrids be better in this provinces depending on different type of risk. So now we're going to talk about flood risk. Flood risk, the provinces that are very vulnerable, as you see in this image, are Santo Domingo, San Cristobal, San Jose de Ocoa, Barahona, Bauruco, San Juan de la Maguana, Sánchez Ramírez, Peravia, and Distrito Nacional. And as we mentioned, they have also a high solar radiance that varies between the 6.4 to 6.6 kilowatt per hour per meter square per day during the summer. So why will this province benefit from microgrids? First, they have a high amount of population. 35.3% of the Dominican population is in the Osama region, and 9% is located in the Valdivia region. Also, urban development. Santo Domingo and the Distrito Nacional are very susceptible to floodings, but also they have 345 medical facilities, 21 fire stations among the Distrito Nacional and Santo Domingo from the 173 fire departments that are in the national territory. So yes, we do need it. And the third point that why these provinces will benefit from microgrids is because of the water treatment plants. When the water treatment plants are not working, there are a lot of endemic and diarrheal diseases, as well as cholera outbreaks, as we saw that happened in Barahona, in particular in the municipality of La Ciénaga. These microgrids here, they can play a significant role in the prevention and mitigation of these diseases by powering treatment plants. So the next risk we're going to talk about is hurricane risk. Hurricane risk. So Dominican Republic ranks fourth among the 10 countries in Latin America and in the Caribbean that with the highest exposure to tropical cyclones. Which makes it that it also is in like the trajectory most frequented by hurricanes, so it's highly vulnerable to this hazards. Hurricanes that have occurred in the country have not only created massive economic losses, but also created damages and left a lot of deaths that have hit throughout history. For example, Hurricane Fiona left damages that resulted in 4 billion Canadian dollars. Yep. And that is like very big. So in addition to the vulnerability, we have provinces here like La Romana and Altagracia that houses a lot of tourist destinations and receive like a lot of immigrant, a lot of tourists that want to be entertained. And this entertainment facilities, like hotels, like resorts, like concert places, need electricity to be 100% there when any of this catastrophe occurs. Finally, we're going to talk about earthquake risk. So, earthquake risk. We are located in this subduction zone between the North American plate and the Caribbean plate. And this makes us a high seismic regions. We have seismic region with 13 geological faults. So yes, if we want to mention something, we want to mention like an earthquake that already happened and then caused damages, just to like showcase that we are very vulnerable, is that in 2003, Puerto Plata was hit by an earthquake of magnitude 6.4, which caused damages to 140 schools and approximately 7 homes in the country. Um, Also, Samana has been struck by a lot of earthquakes, and it houses a lot of people, well, a population of 100,000 people. So in the case of an earthquake occurs, it will leave thousands of Dominicans homeless. So after conducting this preliminary analysis, we have um and that after conducting this analysis, when we mention both the several provinces and also the risk factors, we have ranked the provinces from least to most efficient locations to initiate microgrid implementation based on the number of risks that overlap a certain region. So here, Santo Domingo will rank first because it is like the epicenter of the catastrophic aftermath, and it also allocates 35% of the population. The second position will go to Santiago de los Caballeros because it is both vulnerable to earthquakes and floods. And Santiago is also the second largest city and houses 10% of the population. And the third position will go to Montecristi as it has a high earthquake and flood risk, and it checks both the flood and earthquake vulnerability boxes. Montecristi only allocates 1.1% of the population, but it doesn't mean, as we mentioned before, that it is even though it doesn't allocate a lot of people, it is still vulnerable to earthquakes and flood. So to conclude, we want to say that the integration of microgrids in the end will benefit the Dominican Republic, but it is recommended that the energy sector conducts more studies in this process to obtain like real-time data that mentions and do models that mentions and provides the percentages of success of microgrids in certain areas of selected provinces. So in the end, Dominican Republic has a great potential. It can reach a lot of things. It can accomplish a lot of things, especially because of the high climate change vulnerability that it has. So with a lot of support from the people, a lot of support from the government, shaping and replacing this non-renewable energy resources towards solar energy, I think we can indeed create a better future for the Dominican Republic where people are not scared when flood comes, hurricanes, or earthquakes. Instead, they are sure that their country will respond effectively to these catastrophes. So thank you so much. Bye bye.